This is the time to get asked. Look at the PK. Yeah, that's great. Again, we lost this backwards. Yes, so this is the conjugate base. This is the conjugate base. So this is the one that lost the that was last time. So note again, it goes from here to there to the next one. Okay, so let's go to part C. At what pH is MSG prepared? So MSG is monosodium glutamate. So mono means one, so there's one sodium ion for the glutamate. So if sodium has a +1 charge, in this case here the glutamate has a charge of -1? Bruce? -1? And how do you know it's -1?
Because the sodium has a +1?
Yeah. So at what pH is MSG prepared then? So let's take a look at our titration curve. And at what pH is there a... So the pH which glutamic acid has a charge of -1 is? Yeah, 6.96, because we have a charge of -1 here. And that corresponds to 6.96. Now does that make sense in terms of foods? In other words, should you use a disodium glutamate? Because let's see, for disodium glutamate the charge is going to be, for disodium that's Na2 sodium, so for disodium glutamate DSG, although you never find DSG. For disodium glutamate, the charge on the glutamate is going to be a -2, and the pH at that point is 11.04. So is it better to eat a food which has a pH of 11.04 or a food which has a pH of 6.96? 6.96. Okay, so I'm sure that's one reason why it's MSG and not DSG. Or for that matter, what if you used, let's see, if the charge here is +1, let's see, you can make glutamic acid chloride, okay, because if the charge here is +1, we can make it into a salt by using a negatively charged ion such as chloride, so we could have a glutamic acid chloride. And would you want to eat a food which has a pH of 1.6? How about just plain old glutamic acid with no charge, which has a pH of 3.22? Yeah.
What's the concentration of the HCl in human stomach?
It's like between a pH of 1 to 3, so if you do the calculation, if H plus Yeah, so let's see. If the pH of stomach gas is around 2, then you can say that that's equal to minus log of H plus. Then H plus is equal to 10 to the minus pH power, so 10 to the minus 2. 0.01 mole. Oh, yeah. See, that's the thing, because I've heard it's more, I thought the concentration is higher than that. I'm not sure. I know the pH stomach gas between 1 to 3, we'll say pH of 2, but keep here, I heard some from somewhere else that the concentration of HCl in your stomach is higher, so I'm not sure. Okay, so anything else you need to know about MSG?
Why is that for you?
Well, one problem is because of the sodium. So if people who have high blood pressure want to have a low sodium diet, so by putting MSG on it, that increases the sodium intake. That's not good if you're trying to control your blood pressure. And the other thing too is I read somewhere that with MSG, there's they call it Chinese restaurant syndrome. You sort of get this buzzed feeling from eating too much MSG. You heard of that?
No.
No? So let me see if I can find this article. Because in the American Chemical Society has this on their website. They call it what's that stuff? Yeah, so let's take a look here. So let's see, no, here they have MSG, so I know it's in here somewhere. So they have all this stuff on everything you want to know about trick candles, or body armor, or wasabi, or bowling balls. MSG is in your somewhere. Yeah, so here's MSG. And here's they talk about let's see, so MSG is produced by fermentation. Okay, here it is here. So it says reports of adverse reactions to MSG, collectively called Chinese restaurant syndrome, began surfacing in the late 1960s. Conditions ranging from chest pains to migraine headaches were blamed on MSG. And it says that no credible studies substantiate any harmful health effect caused by MSG. Let's see here. Oh, so
that was published by the Glutamate Association.
Yeah, so anyway. And remember earlier on this semester we were talking about flavors and tastes, and this is way back when Professor Ikeda, from a chemistry professor at the Imperial University of Tokyo and founder of Ajinomoto, he let's see, he isolated a substance in seaweed. He came up with this new flavor. He proposed calling this fifth taste umami, which means delicious in Japanese. So there's sour and sweet and salty and bitter. And here's this fifth taste, which is now part of the standard taste sensations. Okay, so there's sour, sweet, salty, bitter, and umami, which means delicious in Japanese. Anyway. Okay, so let's move on. So I think we're running out of time because we got to take a quiz. Anyway, next week we'll talk about how baking soda buffers our blood. And we know that our blood has a pH between 7.35 and 7.45. It's important that the pH of our blood remains around that pH. Below 6.0 or greater than 8.0 is not a good thing. Then we'll answer some questions. Here's the equilibrium reactions involved. So note that the equilibrium reactions in our blood can involve several equilibrium reactions. So we'll look at these equilibrium reactions on Tuesday in class. And then we'll see that in this blood buffer system, it's actually an open system rather than a closed system. And it's actually very important that it's an open system. And we'll find out why next Tuesday. And then after that, we'll look at hemoglobin is the second blood buffer in our blood. And this is a diagram which describes, for example, here's hemoglobin. This is the basic form. This is the acid form. So here's oxygenated hemoglobin. So there's actually 4 different forms of hemoglobin in our blood. So we'll look at that next week too. And then we'll answer some questions about how hemoglobin works. So here's your quiz question. Glycine is the simplest amino acid. So let's see, how much time do we have? Make sure we have enough time.
5 minutes.
We have 10 minutes.
Just like the K.
No, the K is
Exactly. We use a partner.
No, I'll have you guys work. You guys can work on this one in the group. Okay, so work on this one. If you want to work on this by yourself, you can. Otherwise, you can work in the group. If you work on it in a group, turn in one set of solutions with the names of each person who worked on this quiz. If you speak with another person, that means you're working in a group. So don't talk with someone else and claim you worked on it all by yourself. Because I don't like to see the same